So in this problem, we need to subtract two rational functions that do not have common denominators. So the first step we need to do is we need to actually try to find a common denominator. Whenever you're dealing with two binomials, like we have right here, x minus 1 and x minus 4, since neither of these can be factored, typically our strategy is going to be just to multiply these two together. In other words, I'm going to try to get my greatest common denominator to be x minus 1 times x minus 4. I can do this relatively easily by multiplying the left-hand function by x minus 4 over x minus 4 and the right-hand function by x minus 1 over x minus 1. So let's do that. So I'm going to multiply this guy over here by x minus 4 in the denominator. Of course, anytime I do that to a fraction, I also need to multiply the top by x minus 4. So I'm just going to do that here. And then the same thing on the right-hand side. I'm going to multiply this by x minus 1. And then the same thing on the top. All right, so if I multiply this out on the, oops, let's get that a little straighter. On the f function on the left-hand side, I'm going to have 2x times x minus 4, so I can go ahead and distribute that out. 2x times x is going to be 2x squared, and then 2x times negative 4 is going to be minus 8x. And then my denominator is going to be x minus 4 times x minus 1. Okay, on the right-hand side, I've got 2 minus x times x minus 1. So I just need to, what I'm going to do is actually go ahead and multiply this out because I think I can combine it with some of the things that are going on the left-hand side. And then at the end, after they're combined, we'll see if I can factor it again. So this is going to give me 2 times x is 2x. And then 2 times negative 1 is going to be minus 2. And then negative x times x is negative x squared. And negative x times negative 1 will be positive 1x. So we'll get that. And then again, I should have the same denominator as I do on the left-hand side. X minus 4 times x minus 1. I'm just going to leave this factored out for right now because what I would really like to happen would be after I combine the two numerators, I would really like them to factor so that one of the factors will actually divide out with one of the factors in the denominator. That sometimes happens, not all the time, so we'll just kind of see how it goes. All right, so let's do a little bit of combining here. You have to be a little bit careful on this g function because we're subtracting this entire numerator. So that means that we actually have to distribute this negative sign to each one of these guys, each one of these terms individually. So like this 2x is going to become a negative 2x. This negative 2 is going to become a positive 2. This negative x squared is going to become a positive x squared. And this x is going to become a negative x. So just be very careful with that. Whenever you're doing subtraction, it's a really easy place to make a mistake. All right, so we should end up with 2x squared minus, minus 8x, and then that minus 2x, and then I said all of these signs are going to change, so this becomes plus 2 plus x squared, and then minus x. And all of that is going to be over x minus 4 times x minus 1. Now again, the goal is that in the numerator, I might be able to get some things to combine and then maybe get something that factors quite nicely. So let's just kind of see what happens. All right, so 2x squared, let's see. 2x squared plus x squared, that should be 3x squared. And then we're going to have negative 8x minus 2x minus 1x. So That's going to be negative 8 minus 2. Minus 2 is negative 10. Minus 1 is negative 11, so minus 11x. And then lastly, I just have my 2 hanging out, so I have plus 2. And then this is all going to be over the denominator. All right, so now the question becomes, does that numerator actually factor? And I'm just going to erase a little bit here at the top to see what happens. All right, so if this were to factor, I can use the AC method on there, and I could say that 3 times 2 is 6. So I'm looking for 2 multiples of 6 that add up to equal to negative 11. In this case, I don't think you're going to make it happen because the biggest combination you're going to be able to get is negative 6 and negative 1, which adds up to be negative 7. So this guy does not factor nicely, so I think this is going to just be our final answer. All right, hopefully that's helpful. Like I said, the main thing when you're doing these subtraction problems is to remember that whatever function is being subtracted, you have to make sure that you distribute that negative sign out. That's the place where most people make their mistakes.